What's up, everybody? Welcome to the 4.5 operations for functions. We're just be doing operations for functions. We'll be adding, subtracting, multiplying, dividing them. We're not going to be putting them to. We might put them to an exponent. You know what? Maybe like f squared of x, like how we put sine squared of x, like that. That would be quite cool. F squared of x. But no, not yet. We're not going to do that yet. So I gotta get through this quick. Find the following if f of x equal to 5x, g of x equal to this. So fg of x, we just multiply them together, just like this. Fg of x, fxg of x. So 5x plus 3, multiply that by 4x minus 5, and then you should get 20x squared minus 13x minus 15. That is your answer right there. Next, gh plus f of x. First of all, we gotta multiply g and h first. Yeah, it's order of operations. 4x minus 5, right? And then we gotta add it to f of x, which is 5x plus 3. So 20x times 4, that's, okay, I'm not sure if this even fits. 80x squared minus 100x plus 5x plus 3. So then this will be 80x squared minus 95x plus 3, and that is your answer. Next, h minus g minus f of x is 20x minus g, which is minus 4x minus 5, minus f, which is minus 5x plus 3. So 20x, right, and then minus 4x, and then we got minus and the minus, so it's positive, and then minus this whole thing, so we can turn the whole thing negative. We got 20x minus 4x and minus 5x, so that's 11x, and then 5 minus 3 is 2, so 11x plus 2. Next, evaluate fg of x if f of x is this, g of x is this, and x is this. So first of all, we can either plug it in and then evaluate it, or we can just do the operation with the function first, then plug it in to evaluate it. So that's what I'm gonna do. I'm gonna do the operation first. So fg of x is these two multiplied together. We're gonna multiply that by that. So 2/3 times 2/3 plus negative 1/3 is 1/3, and then 3 times negative 4 is negative 12. So negative 12x to the 1/3. And then if we plug negative 64 in, negative 12 times negative 64, so 1/3. We all know what negative 64 to the 1/3 is equal to. It is the third root. So we can get rid of that. And then the third root of negative 64 is negative 4. So we got negative 4 and then negative 12 at the outside, which will give us 48. There you go. 48 is the answer. Next, evaluate f over g of x when f of x equal to this and g of x equal to this. So there's really no way to actually combine these two equations other than do this. 2 plus x 30x. That's the only way. Yeah, that's the only way to put it. That's the only way to put it. So this is our f of g of x, f over g of x function. And then when we put 2 in there, we'll get square root of 4 over 60. I'm feeling nice today, so my questions aren't hard. 2 over 60, which is equal to 1 over 30, and that is your answer. Next, I'm speeding through these. Oh god, okay, I have my phone, that's good. Evaluate when x equals 4, f g of x when f of x equal to this mess, and g of x equal to this mess. Okay, let's do it. 38 minus, I'm gonna put everything in because I have to. Okay, 7 over 9 minus 4 squared, and then f times g of x. So put all these in the parentheses. 2 over 4 the 3/5 power plus pi. Okay, so the first thing that I can do is I can simplify some of these. So 4 squared is 16, right? And then 4 to the 4th power is 256. Now, granted, if you don't know that, it'll obviously be harder for you, but I know that. So, okay, that's negative 218. to the 7/9 power. That is such an ugly number. I'm gonna be really honest with you. Minus 16, and then multiply that by 2 over 4 to the 3/5 power plus pi. Right? Okay, so first thing that I'll do, I'll solve the left side, right? Okay, so what's 216 to the 218 to the 7/9 power is also 218 to the 9th power and the 7th root, right? So we can do, I'm just going to pull up a calculator right here. So we'll do, there's probably an easier way, but 218 to the 9th power, right? And leave it to the 7th root. So then you will get negative 1015. Actually, wait, no, I did it the wrong way. Sorry. It's the 7th power and the 9th root. 7th power and the 9th root. So we're going to do negative 218 to the 7th power to the 9th root, which will give us minus 65.88. Minus 65.88 subtract 16, that's minus 81.8, actually 89, because I'm going to round that. Okay, minus 81.89, and then we're going to have 4 to the 3/5 is the same as 4 cubed, the 5th power, 4 cubed. The 5th root of 4 cubed, so 4 cubed is 64, and then the 5th root of 64 is 2.2. 2.2 plus pi is 5.438. 2 over 5.44. What is 2 over 5.44? That is 0.367. 0.367. Multiply negative 81.89. You will get negative 30.11, rounded to the nearest hundred. Negative 30.11 is the answer. That was a roller coaster of a ride, but that's how you use technology. You solve each individual section. So basically, when there's a mathematical wall, that sounds really cool. When there's a mathematical wall like a parentheses or a divider like this, you solve every single compartment. It's like a wall dividing, whether you're allowed to solve it or not. And in order to remove that wall, there's certain steps that you have to do, and these are certain steps. Number 4, visual transformation. Okay, I think this is really messy. Anyways, this is a visual transformation. Based on how the graph is supposed to be. So for example, we have this graph right here, right? This graph right here, x plus 1 squared minus 6. Where's my x plus 1? X plus 1 squared minus 6, right? And then wherever this if we transform it by x over 2 plus 5, wherever the graph is at, it transforms it up. So it transforms it to that point. So for example, if the graph is at, let's say the point is 3, 1, right? This isn't a really good example, I know. If the point's 3, 1, and then the graph of this point is, let's say, 1/2. We're gonna use a nice number. We're gonna use 2, 6, right? And then we add these 2 points together, we'll get 5, 7, and that's your point. That's your new point, right? It's kind of like a vector. It's kind of cool. 3, 1 plus 2, 6 will give you 5, 7. That's the new coordinate. It is really neat. And then let's say you have like 4, 2, right? Plus 4, 7. Add them together, you'll get 8, 9. 8, 9. 8, 9. See? So basically, but 4 isn't actually isn't actually 2 in this graph. It's 19. But whatever. That's basically what I'm trying to show you. Oh god, sorry. Okay, modeling mathematics. From 2005 to 2009, the number of cruise ship departures in thousands are multiplied by these equations, where t is the number of years since 2005. Find W minus F of t. Oh god. I'm just gonna do this. I'm really lazy, I'm sorry. Minus 5.8333333 t cubed, that is going to get you, it's going to get you negative 17 and 1/3. Negative 17 and 1/3 plus, no, t cubed plus 77.72 t squared plus 300 and I don't want to do, okay, it's 0.5 27, so 72 372.5 t, and then plus, yeah, I'm not even gonna do this. I'm not even gonna try to do this. 5 1 6 6, okay, 6615 plus 6615. So this new equation, right, W minus F of t, this represents the amount of cruise ships that travel from around the world, but not in Florida, because we're subtracting away Florida. Next, table shows the output of the values of two functions f and g. Use the table to evaluate f plus g of 3, f minus g of 1, f g of 2, and f over g of 0. So as you can see, there are these we have all the values basically. So f plus g of 3 is going to be 10 minus 31, which is negative 21. F minus g of 1, negative 4 minus negative 3, negative 1. Fg of 2, 0, and fg of 0, negative 2 over negative 1, that's 2. Simple. Okay, anyways, I'm sorry about that interruption. This is question 27. Question. Elvis runs at a speed of 6.4 meters a second. Write a function r in terms of x represent the time he runs then from running from point A to point B. So this, and then write the function that represents the time he runs from point D to point B. So the time that he runs from point A to point D, that's x, and the whole thing's 20. So the distance from point A to point D is 20 minus x, right? So that's r. So r of x is equal to 20 minus x, and then he runs at a speed of 6.4 meters per second, so divided by 6.4. That's the amount of seconds. Next, we have, not minus 6.4. Next, we have, write the function s in terms of x. Represents the time he spends swimming from point D to point B. Now, point D to point B is the result of a hypotenuse. So we can do the Pythagorean theorem because there's a right angle right here. So x squared plus 12 squared, x squared plus 144 is equal to db squared, right? So db will just be the square root of x squared plus 144 right here. S of x is equal to square root x squared plus 144, and then he swims at a speed of about 0.9 meters per second, so divided by 0.9, and that are your two functions. Now write function t in terms of x, that represents the total time Elvis spent traveling from point A to point D to point B. We just combine these two functions together, so t of x is equal to r plus x, s of x, which is equal to 20 minus x over 6.4 plus the square root of x plus 104, x squared plus 144 over 0.9, and I'm just gonna make this go up to 6.4. That will be multiplied by 7 and 1/7. This is a lot of work. So 50 over 7. multiply the bottom by 50 over 7 as well. Is it 50 over 7? Multiply by 7 to get 6.3, and then multiply by 1/9. No, it's not. It's 64 over 9. 64 over 9. 64 over 9. So you will get 20 minus x. Okay, I'm just going to clear all of this. Clear all of that. Clear that. You will get 20 minus x plus 64 over 9 times the square root of x squared plus 144 all over 6.4. And we don't like to leave decimals down here, so we can multiply everything by 5 to get a better fraction, but I'm just going to leave it like this. That is the function t of x, right? Use a graphing calculator to minimize t. Now I'm gonna use I'm not gonna use a graphing calculator because that will take forever. I might put like a graph of the thing at the end. I probably won't use a graphing calculator, but that's gonna be it for today's episode. It'll probably be somewhere pretty close to d, maybe like right here. Yeah, but I won't use a graphing calculator because that'll just take too long. But that's gonna be it for today's lesson.